Hello everyone, welcome to the second part of our Pandas series and data frames. Today we will dive deeper into data handling with Pandas, exploring advanced concepts like descriptive statistics, data aggregations, and more. Let us get started. We will cover descriptive statistics, data aggregations, and sorting. Then we will look at group by functions, which will help us aggregating data across various functions by group of your subset of data. Like what we have seen earlier for series and all, you can actually alter the index. So we'll have a look at some of those things. And then we'll look at some of the advanced concepts around pivoting, reshaping, etc. We'll spend some significant time with a pivot table in Pandas. Handling missing values, that's another very, very important topic in Pandas and useful from machine learning perspective. So we will have some hands-on exercises and we see how we can impute missing data and look at several strategies for that. And then it's very important that sometime you access data from your MySQL data sources in Pandas and vice versa. So we'll organize our today's discussion around this. We start with, we'll focus on set of statistical operations supported by Pandas. Pandas makes summarizing your data effortless with functions like max, mean is MIN minimum, and then mean, which is the average one, that is MEAN, as well as STD for a standard deviation and FAIR for variance. We can quickly understand the distribution and variability in our data. For example, with just one line of code, df.describe, you get an entire summary of your data set. This is incredibly useful when exploring new data or performing quality checks. Now, from set of operations or set of functionality that are supported by default on your data frame. So for mean, so we have actually taken, if you see on right hand side, we have created a simple data frame with one column, that is scores, and we have given it values like 80, 90, 70, 60 and 85. So on this data set, as you see on df.scores, df, and then we are accessing it for column scores. You can call mean, you can call median, you can call mode, right? So these three, as you know, will give you mean, median, mode, as you generally understand as per your basic stat knowledge. So mean will simply sum it up and then divide by number of data points. So here, if you see, mean will be around 77. Median is, it will sort it. So it will your data will look like 60, 70, 80, 85, 90. In that sense, 80 will be your median. And since none of the data set are mode, by default, any random number will be returned as mode. Quantile is pretty interesting, where you can provide a range between 0 and 1. Typically, the one that are used are for first quartile 0.25, then for median 0.50, then third quintile 0.75, that way. So here if you look at the first quintile for your DFS course, uh, that will be uh, 70, right? Because it is actually looking at 60, 70. So basically there are 5 data sets, right? So almost everything is, one data set is kind of 20%. 70 actually comes around 25th. Uh, on mode, I actually, if you look at by design, it returns all the data sets with maximum number of occurrence. So here, since everything is single, it returns everything, right? Now variance and standard deviation. So for that, if you see, the call for that is .std, as you might see in the last line, where you are actually calling for a standard deviation on this particular scores. We are calling, uh, you know, .std. If you want the variance, you can actually call .var. So this was a basic slide where actually by using describe and then explicitly calling mean, median, mode, quantile, and then a standard deviation and variance related functions, you can get those data set uh, summarized and be available without you requiring to write any actual code. So you should actually practice with it. They are simple. What happens is when you actually go through lot of different utilities of Panda, it's hard to recall and then kind of connect when you are actually solving a specific aspect of your problem. So better actually as you are progressing through your course, practice more and more. That's what that will make you comfortable. Now, uh, with basic review of descriptive statistics, let us move to next utility where uh, we will learn how you can sort a data. And the example that we are taking up is something where it's a product, sales and profit. So on right hand side, I have just kind of used the code to create this table where products are A, B, C, and then your sales and profit, as sales is 500, 400, 600, profit as 50, 60, 40. Right now, coming back to it, before we get further, there are two major variations. One where you call sort values, and as you might see here on the left hand side, this part. So in sort values, you can provide the set of columns by which you want to sort. Right. So by is equal to column, and in a list like notation, you can provide one or more than one column, right? And then ascending, by default your data is sorted in ascending order, but individually for a specific column you can actually have it set to false or true. uh, Remember, when you leave it, data will be sorted in ascending order, but when you actually set it false, data will be sorted in descending order. If you look at in so we are actually taking a little complex example of multi-column sorting, where we can pass multiple columns. You can see the example df dot sort by, where you are giving by is equal to in a list like notation sales and profit, and for ascending you are setting up false for sales. It means that your sales data will be sorted in descending order, right? That makes sense. Also, you want to look at maximum sales first, while somehow you want to look at, in this particular example, say profit in increasing. So this is set. So this particular table that you see, right, where your sales was 500, 400, 600, your profit was 50, 40, 60. If you sort it on sales and profit using by is equal to and list notation, uh, then and if as you have set up your ascending is equal to false for sales, So sales will be in increasing order and profit will be decreasing order. That's what profit will be in decreasing order because there you have set it accordingly. So uh, if you see the example here, right? Uh, your 500, 400, 600 is becoming on sales for 600, and associated with 600 your profit is 60. Then it is actually going on to next column, that is 500, right? So the next one is, let's see, and 500 is 50. The next one is 400. Now you might be worried that I wanted to sort it on sales by increasing and profit by decreasing, but the final output that I'm having is not in that particular order. Thankfully, in this tiny data set that we were having, but eventually what happens is when you sort by sales, right? Your that order will stay as it is. Now there, if you are having a set of values which are equal, there it will be actually sorted by your profit, right? Okay. So before we so just to summarize, right, our sorting related and looking at some utility. So sorting data, uh, it could be important. Say for example, when you want to find out ranking a student by grade or to find the highest selling products, right? Uh, as we saw in this particular example. So with pandas, we can sort values using sort values, or you can also use sort indices, right? Where there you have to use sort underscore index. Uh, Now, for we also looked at actually flexibility and several scenarios where we can actually have a different combination of ascending and descending for this particular uh, case. So handling missing values. This is um, if you look at in any real world data science problem, missing data is a reality in almost every data set. And thankfully, Pandas provides robust methods to handle these gaps. To start with, there are several utilities using which you can list the set of attributes which are likely to have missing values. We'll actually just look at those uh, a specific function name, and once you have found it, you can either use a strategy like fill with an age, or you can actually even impute with you know several strategies like the maximum repetition, the average, and so many of those are available. And altogether, as a very very simple step, you can drop NA to delete the set of records which are kind of missing, right? So eventually, once you have handled your missing data set, either by replacing with a suitable replacement as per needed as per your project strategies, or by dropping them, that ensures that your analysis remains accurate without being disrupted by incomplete data. Now, uh, on your data frame, right? If you call dot is null, and then you call sum on top of that, right? So this will give you the set of variables which are missing, right? uh, then of course, as we discussed, you can actually on a given column, you can either fill your NH, right, with, say for example, the one that you see here is on this column. What we want to do is filling the NS by mean, right? And in place is equal to true means you don't have to assign it back to the same or different data frame. It will be done internally for this particular column. So for column wise, you can have different strategies. Now looking at a very very small data set, we have actually name, age, and country. Where if you see, we have all the names, but country is missing. As you can see, the third country is missing, and age wise data for second and the last one is missing, right? So if you call on this particular data frame is null dot sum, right, you will be getting for age and for a country, the set of non-zero numbers, because there are several and missing data set. And then you can focus that what do you want to do in case of age. For example, in case of age, one simple strategy that people use is use the say mode of the data set, right? Because it could be that the one that is missing is likely to be amongst the most frequent one. Another one is you can take the mean of it, right? So you can take uh, on this data set you can actually simply take mean, and then you use that mean. But for countries, these are categorical variables, and definitely mode like operations are better. So if you see, just by printing df before, as you can see on the right hand side, you could see that on age there are two missing data, and as well as in country you have one nan, right? Now if you call, what we have done is we have created a df after, where we are copying our data from before, and say if you call fill na, right, where actually you are filling by the mean of this particular column, right? So uh, it means that all your missing data set, right? So if you see in this particular case, the two data sets that were missing got replaced by the mean, which was 25, right? As you can 25.67, right? For country we have used mode, right? And we have taken the zeroth, so it means that the first uh, first one, that is, and actually as you see in this particular case, we have found Australia, right? So post this handling, your age is set to actually the mean of the data set, and your country is set to mode, where actually we randomly took in this particular case Australia by calling dot those position based location, and the zeroth one on this particular column, which came to be Australia. So in a similar way, on a some other data set, you can actually call isNull.sum and run it end to end and see and find your observation. Um, so from here on, what we will do is we'll actually focus on uh, bunch of aggregations, right? Uh, and there are several data aggregation utilities, right, available in Panda. But let's talk about grouping data for better analysis using GroupBy, right? So the GroupBy function in Panda is actually a very flexible and a very well versatile utility for aggregating data, right? So if you have sales data, you can group it by say region or product categories to analyze trends, and that uh, that enables you that can enable you to uncover insights like say sales by region, or average sale per product, or those kind of utility. So we'll spend some time where we'll actually, and now if you look at, there are set of utilities uh, like some mean, right, which is available to you, right? So uh, you can actually aggregate it for using sum, using mean, or you can have your own actually custom functions where you can apply these aggregations, right? uh, the typical, if you simply look at your previous data set that we had, right, where we are having this, right, product, sales, and profit, right? So we had ABC, and there, if you look at your sum and mean, right, since there is no repetition across product, it was unique. So if you call group by, right, so df dot group by on product, and Then we actually apply on our aggregates using dot aggregates, where we are actually applying bunch of these sum and mean, right, on sales data set, right? So had you had some duplication on A, you would have seen that how those sum and means are getting available. We'll not just stop here. After introducing the basic sum and average and idea about custom aggregations that you can do using dot apply, let us deep dive for a single and as well as multi-column aggregation, and then also actually our ability to give custom name, because you might be seeing here, right, all of a sudden this sum, this mean, right, you would like to give it a proper name. The column has changed, right, the new column. So what happens, when this grouping by and creating more and more metric, they are assigned newer column other than the data set that you are having yourself, right? So by default it just takes a function name, right? But doesn't make sense. You'd like to have this sales, total sales, for example. When you sum sales by product, you'll get total sales. Otherwise it will get product wise mean, right? Or average by product, right? You'd like to give meaningful column names, and we'll see the set of APIs or the that you can use to accomplish that. So on the same sales data, say that you want to group by on product, right? So what will happen? Your data is grouped on product. Um, I would have actually taken if I have not, we are actually going to have another video more on the advanced aggregation ability provided by Pandas. So we'll have actually more meaningful example. But imagine if there was a uh, 2A here, right? So and maybe one having cells of 500 and another having cells of 400. You can actually assume that your sales sum mean or profit mean would have been actually accordingly computed, right? But what you can focus here is, once you are actually create, what is happening here, you are applying sum and means on sales. So these are the way. Once you call, what you do, look at the syntax first. Df dot group by. So df was your data frame, and you are grouping by on product. This is one way of writing syntax, right? Once you have grouped by, you are calling aggregates using dot agg, and then what you are having is you can have multiple different aggregation or on different columns, right? So on sales, say you are having sum and mean. The way you do is you specify the um, uh, column name, and then in a key value pair notation. In fact, this is actually, if you look at inside age where it is closing, it is actually a dictionary, right? And how this dictionary is column name followed by list of aggregate functions that you want to apply, right? So here you wanted to apply sum and mean, right? Then on profit you wanted to apply max and mean, for example. So you have, and then actually individual sales and profit, they are separated by comma, right? So this is how you can do. Say actually, there was another column called region. So and on region you wanted to do say more again max, right? So you can again actually say by comma and then region underscore, and then there you can provide a list of mean, max, whatever you want. Now once done, you know that there will be four different columns. You're getting my point? This will create sales sum, sales mean, profit max, profit mean. So accordingly, if you want to rename it, you can say that group dot columns. You can actually provide a specific column out here, right? So sales, then sales, then which metric, sales which metric, profit which metric, profit which metric, right? And then if you print, you'll actually get your data more organized, like on which column it was grouped by, and then what was your actually different metric that you computed. So important thing, before you move from here on, you can stop this video, look at this repeatedly. What you should focus on, if you are done with group by your 12th or for any introductory course, right? uh, you know uh, for coming several decades, right? For more often than not, you'll be using group by in pandas, right? And the many people, what they struggle is once they don't write this code for some time, what is the syntax, right? So it's very simple. On the data frame or the subset of data frame that you want to apply, either one thing is that you are going to provide by, or the one that you are seeing here, where in a um, you know this is bracket, you have to provide the set of column, and then you call the aggregate function, right? Inside the aggregate function you give the key value pair, where your key is column and value is actually set of metrics that you want to do in a list, right? And yeah, so that's important. Now, if you look at another introduction, and before this we have made some change. So we have region, right? Say east, north, south. Then we have product, say C, A, B, and then we are having cells, different cells, right? So, like just as a review, what group by and how group by works, right? It splits the data set into groups based on key columns, right? So if you want to do group by on region, thankfully here are only east, north, and south. But say there was another east, right? So all the east will come together, right? That's one. And then on top of this, of which all column you want. Say you wanted cells, right? So if you want to apply aggregation function to each group, you can actually call your sum means whatever that is here, right? Then on these grouped elements, you want to give a new column name, you can give it. You can reset the index so that everything starts from 0, 1, 2 and something like that. And then what you will get it, your region wise, whatever matrix that you are getting. So this is the left hand part that we are talking about. On right hand side, we have tried multi column, aggregation. And if you see what we are doing is we are again group by. But here, if since there are more than one column, you provide them in a list, right? List like notation. And on top of this, uh, we have just taken the sales part of it. So we are grouping by region and product, and then we are taking sales on this, where we are applying our aggregation for sum and mean. So this is the third notation that you are seeing, right? Whenever uh, had you wanted actually say another column and another aggregation, as you could have actually provided them as a key value. I understand looking at several variation of it could be little daunting. What you can do is practice, and maybe initially choose one that works best with you, and then make it something that you can actually write it very easily. There will be several exam questions that will be tested on this, right? So then actually grouped columns, and then eventually you can actually move ahead with your next item. Now looking at some advanced examples, so as we saw, you can have more than several, right? So sum, mean, and count, if you see here, right? Um, right. So multi-group, and what we are having here, uh, grouping by region and product, and then on cells we are applying sum, mean, and count. So you get sum, mean, and count, right? Then say that you group by region, and on top of that, the what we are looking at, right? Aggregate, right? And then here itself you can actually name it, right? So if you see here, average profit is your profit by means, your total sales is sales by sum. So this is the fourth variation that you are seeing. Inside aggregation, you can start with giving a column name, right? So total sales, and then you say that what you are doing, sales and sum, average profit, profit and mean, right? You can assign here itself, you can assign later itself. I think what I'll prefer is you focus one where you give group by, then provide the set of column. On top of that, call aggregates, and then practice with key value pair for more than once, and then explicitly set the renaming column name, and then look at your output. So we'll actually, again, we will actually have a very interesting exercise on this. Um, and because we are actually not covering another very very important topic, that is pivot. So we have another small video coming up in this topic. But for time being, let us move to the next topic, where how to interact between pandas and mysql, right? So basically how you are going to integrate it in pandas. We are having actually for importing pd.read sql, and for exporting dot to sql. Just like how you read on read csv, how you write to csv, right? So similar thing, right? Read underscore sql to underscore sql, just you can actually remember read CSV kind of exam. How we do it, there are, one thing, the way you can do it, there is SQL alchemy, right? So we can import it, and then we can actually get the create engine by providing our host name, password, right, and the database name, right, the one that you see in the bracket here. Once done, you can actually call your pd.SQL, where you can actually provide your query like select all from table name and then execute it through the engine, right? So this is the interface. And when you do df.SQL, you can actually provide the new table that we want to provide the engine and some other variations that you have, right? So uh, here there will be some libraries to be installed, right? And once done, what we'll do is we have written it a very, very, um, short form. In case you want to remember, we'll actually expand on this and have actually a couple of slides just after this, where we'll actually individually cover each of these portions. And you must pay focus, because every year so far in the exam, interconnectivity between Pandas and MySQL is being tested. So to create table on SQL side, right? Create, so for example, you first create a database, a sample database, or it could be your attendance, right? It could be your, if you're say making it something for your project as an attendance, then you use. So you have created a database, then you use, and then inside that you have your create table, right? Where actually you can provide your IDs, name, age, these are your columns, right? And then you have actually provided its data type, right? Auto increment is automatically increment, and otherwise it is and then primary key, actually you are declaring that ID will be your primary key, right? Now if you want to insert into this, what you will do, insert into sample table, you can actually give your name, age, right? If you want to just enter name and age, because ID is, you have set it to auto increment, so your values will be say John Doe, Jan Doe, Bob Smith, right? So you have actually given this key pair, and eventually now you will be having your these three students, or three, whatever you want to call with their age available in your table. Once done, now this is very important, and this is a slide that you actually have to kind of read it multiple times and again. So when we want to read data from MySQL into Python, right, you have to import anyway MySQL dot connector, right? Pandas anyway is there, and on MySQL dot connector you get API like connect, right? So this is to establish a connection to the MySQL database, right? So on MySQL dot connector you'll get, actually you'll call dot connect, where you provide your user, right, which is your username, your password, your host, and your database. In your exam questions, all of this will be given. What you need to remember is you have to import MySQL.connector, and you have to call .connect. This is what is important from your exam perspective, right? Then once done, you can actually call pd.readSQL, where you can actually provide your query. Say for example, select all from sample table, right? And then what you have to pass on, just the connector.connect, the CNX, right? That's the only thing that you need to take care of when you are talking about creating a pandas data frame from the MySQL table, right? Now if you want to print, you can print it here, and once done, if you don't have any activity to do, you can actually close it by calling cns.close, right? So this is a very simple connector. You've seen another video of ours on SQL, where we actually talked about pretty same thing. Now again, if you want to write data, right, from Python into SQL, what you can do, say you have got your data, right, for this additional one, Alice, Mike, Emma, right, and their different ages, and you have created in a data frame locally, right, which is actually just like your name is, right, the one that you created earlier. So again, you need to establish the connection by calling MySQL.connector.connect, where you provide user, password, host name, and database. And once done, you can actually directly call df to SQL, right? So here we are calling pd dot read SQL. Here you'll call data frame to SQL, right? And then you can name the name of the table. You can provide the connection ICX, CNX, and what it is saying is, if this data exists, then you have to append so that it doesn't destroy, right? And it is saying that index is false. Once done, you can actually go check back query, and otherwise you can close this connection. So what is important here is, the only thing that you do is get this CNX of connector, that you will get by calling on MySQL.connector.connect, and in every command of yours this will play a role, one of the column, right? Now so what we'll do is we'll try to sort of quickly recap, right? um, our import and export of data between Pandas and MySQL, and then we'll cover on our last topic, which is altering the indices and all, right? So as you saw, Pandas, doesn't only just stop at CSV file. It can integrate seamlessly with databases like MySQL, and using library like SQL Alchemy or PyMySQL, you can read data directly into a data frame or export it back to your database. So this is valuable when working with large data sets stored in relational databases. For example, you can execute a SQL query and instantly analyze the data in Python, right? So that's why actually it is very, very important. Now we'll come back to our, uh, altering the index part, right? So here, uh, if you see, for altering the index part, right, sometimes you might need to set a column as the index for easier referencing, or need to reset it back to a default integer based index, right? So with set index and reset index, you have complete control over how your data frame is indexed, right? So this is particularly useful when working with time series data or unique identifiers like product IDs. So just three things: set index, reset index, and rename axis if you so want. What we have done here, we created a simple, data set, and then you have set index as name, uh, right? So if you call the, a set index as ID, right, and then rename it as, a name, you can see it, right? Your data is earlier name and age, and now your age is indexed by name itself, right? Second part. So you have to keep in mind set index, reset index, and rename axis, because these will be actually again commonly used in our. So with this we come close to end of, large part of what we wanted to cover in Pandas aggregation and some of the advanced concepts. We are left with one more topic, that is actually, broader set of aggregation in a very, very generic way using pivot tables. That is also part and covered in your exam. So I'll be having another short video on that. Um if you like the content, please like, subscribe, and comment. If you have any specific question, do ask that. We'll try and respond to that. I hope to see you in our last video on data, uh, data pandas aggregation. That will be our pivot table. Thank you, guys.